Hi Chemistry, Mrs. KJ here, going over lesson 4.04, the ionic bond and salts. Ionic bonds form the salts of our Earth. In this lesson you will learn about ionic bonds and how they form. You will also learn about the structures of ionic compounds. So salts are formed from a metal and a nonmetal. The metal loses electrons, becomes a cation. The nonmetal gains electrons, becomes an anion, and they're held together by a force that we call an ionic bond. Now, when they're talking about salt, of course, we can talk about table salt, which has what formula? NaCl. But as we've talked about from labs, we can also call any leftover ionic compound a salt. So instead of NaCl, we could have KCl or NaBr. Those would all be examples of salts. Goals for the lesson: describe how ionic bonds form, describe how metallic bonds form, describe an ionic bond, define a salt as an ionic compound, analyze the repeating patterns of positive and negative ions in salt crystals such as NaCl, determine what holds the positive and negative ions together in salt crystals such as NaCl. If you want the student guide, you'll have to go into the lesson to download it. Explore the ionic bonds and salts. People have used salt for tens of thousands of years. So here's miners descending into a salt mine. Ordinary table salt is a substance you are familiar with. It has been used for tens of thousands of years. Besides using salt for cooking and flavoring food, people have used it to preserve meat in the absence of refrigeration, like jerky. It is used to make paper, soaps, and detergents. Salt helps us set dyes in fabric and to tan leather. People use salt on roadways to prevent them from icing up. In ancient times, salt had many uses. The Egyptians used salt to preserve mummies. The Greeks used salt and water to heal wounds. Salt was also an economic resource. The Chinese used salt as money, and Roman soldiers were paid with salt. The origin of the word salary. Salt was taxed by the ancient Chinese and by the French and the British from the Middle Ages through the 18th century. In the United States, the Erie Canal was financed by salt revenues. And now we don't think anything of salt. I mean, it's like 80 cents for however many pounds of it at the store. But it used to be a huge commodity. Table salt is an ionic compound. The name for table salt is sodium chloride. Its chemical formula is NaCl. We know that table salt contains the elements sodium and chlorine. But in what form? And what forces hold the atoms together to make up the structure known as table salt? Rather than sodium atoms and chlorine atoms, sodium chloride is made up of sodium ions and chloride ions. Sodium atoms lose an electron to become sodium ions, while chlorine atoms take an electron to become chloride ions. But what makes sodium atoms lose an electron to become positively charged? And why does the chlorine take an electron to become negatively charged? So let's look at what we're making. We're making table salt. Sodium and chlorine come together to form common table salt. And what it's made up of is really amazing. It's made up of this yellow poisonous gas and sodium. Sodium burns in the air and it has to be stored in oil. So this is actually oil that it's sitting in, because if you were to put sodium in water, what would happen? So in this beaker is water and a piece of sodium about the same size as your smallest fingernail. And watch what happens. It starts on fire in water. And yes, even a piece as tiny as your fingernail will make that big of an explosion. And sometimes it will even shatter the beaker. So that's why they have this other container around it in case the beaker shattered. Sodium loses its valence electron readily to become a sodium ion. What makes sodium atoms give up electrons to become positively charged? And why does chlorine take an electron to become negatively charged? Sodium has 11 electrons, one more than neon. That additional electron is sodium's valence electron, or the electron in the outermost shell. Now recall that sodium is a group 1A element and has a relatively weak electronegativity. It does not hold on to that valence electron tightly. So relatively little energy is required to remove the electron. When the valence electron is lost and sodium becomes a sodium ion, it has the same electron configuration as neon. a full outer shell of 8 electrons, which is a stable configuration. The sodium ion has 1 fewer electrons than the sodium atom, so it still has 11 protons, but now it has 10 electrons. 11 minus 10 gives it a +1 charge. All right, so here we can see the Bohr diagram, and we can see that that 1 valence electron is going to be lost, and when it is, that outer orbital's gone, and now look at this. It only has 2 orbitals, and what's true about the outer orbital? It is full, and so it is stable. So again, 1 valence electron, it wants to lose it because now it only has 2 orbitals. The outermost orbital is full. It has a full outer shell and it is stable. All right, so let's look at the other part. We're going to look at chlorine now. Chlorine gains a valence electron to become a chloride ion. So let's look at the picture first. So if we look at our Bohr diagram, chlorine has 17 electrons. How many go in the first orbital? 2. How many go in the second orbital? 8. So 2 plus 8, I'm up to 10. I have 7 left over. How many total electrons does chlorine want in its outer shell to be full? 1 more, for a total of 8. Now it has 17 protons, but how many electrons total? 18. So 17 minus 18 equals -1. Chlorine has 17 electrons, or 1 less than argon, a noble gas. The 7 outer shell electrons are valence electrons. Now recall that chlorine is a group 7A element and has a relatively strong ionization energy. In contrast to sodium, chlorine holds onto its valence electrons tightly because it only wants 1 more, which means that a lot of energy is required to remove chlorine's valence electrons. So it's never going to happen. Chlorine's never going to lose electrons because it hangs onto them too tightly. Furthermore, it attracts electrons from other elements. That is, chlorine has a high electronegativity. When the chlorine atom takes a valence electron from another element like sodium, it becomes a chloride ion. The chloride ion has the same electron configuration as argon, a full outer shell of 8 electrons, which is a stable configuration. The chloride ion has 1 more electron than the chlorine atom, so it has a net charge of -1. Now, if you're wondering, how come this is chloride instead of chlorine? It's because when you properly name a compound, you change the ending element to "ide" instead of "ine. So that's why. So we could say a chlorine ion, but they're trying to get you used to saying that the name's going to change. Ionic bonds involve an exchange of electrons. So, woohoo! All right. So, yes, restart. So sodium's going to lose. It's going to come over to your chlorine. They're going to both have full outer shells and be stable. Consider the reaction between sodium and chlorine. When sodium and chlorine react, sodium's single valence electron is transferred to the chlorine. The products of this reaction are a sodium ion with a +1 charge and a chlorine ion with a -1 charge. Electrostatic interactions, also called electrostatic forces, occur between positively charged sodium ion and the negatively charged chloride ion. Electrostatic force, the force by which positive and negative charges are attracted to each other and by which like forces repel each other. In other words, anytime you think of electrostatic, you should think positive and negative attract. 2 positives will do what? Repel. 2 negatives will do what? They will also repel. The electrostatic interaction becomes a strong chemical bond between the 2 ions. This kind of bond is called an ionic bond. The ionic bond is a strong bond, not just a weak association. So in other words, it's not kind of by each other. They are super strongly attached to each other. Ionic bond, the force of attraction between a charged atom or group of connected atoms and another with the opposite charge. So a cation and an anion being attracted to each other, making a compound, is going to be an ionic bond that holds them together. It represents a stable configuration and requires a relatively large amount of energy to be broken. So it can be broken. We can break chemical bonds, but it takes a lot of energy. Sodium ions and chloride ions form a crystal. So if you ever look at table salt, you'll notice that they are cubes. Well, the reason why is because look at how they stack together. negative, positive, negative, positive, negative, positive, but then a negative, a positive. So they stack together in the cubic formation. Sodium ions, and because it's not just like they're attracted this way to each other, but this one wants to be next to a different negative. Okay, so if you notice, it's every other one all the way around and in 3 dimensions. Sodium ions and chloride ions don't normally move freely about except in solution. So if you put them in water, then they'll move around. Otherwise, they're stuck. At room temperature, sodium and chloride ions bond together in large lattices, or regular geometric frameworks of ions alternating between positive and negative charges. These lattices, or the cubes, are called ionic solids or crystals. Ionic bonds hold ionic solids together. The sodium chloride crystal holds an equal number of sodium ions and chlorine atoms. Each sodium ion is surrounded by 6 chlorine ions. Remember, it's in 3 dimensions. Likewise, each chloride ion is surrounded by 6 sodium ions. The overall ratio of sodium ions to chlorine is 1:1. Hence, the chemical designation NaCl, indicating a 1:1 ratio of the ions in the ionic solid, held together by ionic bonds. The crystal is tightly packed. All right. Crystals are made from repeating units called formula units. So the fact that we have this cube is because here it's repeating positive, negative, positive, negative, positive, negative. Sodium chloride is composed of a large array of alternating positive sodium ions and negative chlorine ions bonded together. The ratio of sodium to chloride is 1:1. So the simplest whole number unit by which you can represent sodium chloride is the chemical formula NaCl. NaCl is called the formula unit, which is the lowest whole number ratio of ions in an ionic compound. All right, so add that to your notes, hit pause. In other words, there's always going to be 1 chlorine for every sodium. That's its formula unit. So there's like 100 here. Okay, 100 just where my mouse is. We're talking like millions of these, trillions of these. So I don't say Na a million, chlorine a million, right? I reduce. Na1, Cl1. Another example of repeating units can be found in the ionic compound called calcium chloride. In calcium chloride, 1 calcium ion with a +2 charge is bonded to 2 chlorine ions with a -1 charge. The crystal has repeating units of 2 chlorine ions to every 1 calcium 2+ ions. So the formula unit of calcium chloride is CaCl2. The reason there's a 2 here is because calcium has a +2 charge. The reason there's only 1 calcium is because chlorine has a -1 charge. Every time you have 1 calcium, it's going to be bonded to 2 chlorines. Most salts form when metals form ionic bonds with non-metals. Table salt is just one of many ionic compounds. Ionic compounds form from metals, groups 1 through 3, and non-metals, groups 5A through 7A. The metals give up their valence electrons to the non-metals to form metal cations and non-metal anions. The metal cations and non-metal anions form ionic compounds or salts. Remember, any ionic compound is called a salt. But if we're specifically talking about table salt, it is what? NaCl. And they arrange into crystal lattices. Each crystal lattice has repeating units called formula units. For example, calcium combines with fluorine to form calcium fluoride, whose purple crystal has a lattice repeating of CaF2 formula units. The ratio of calcium ions to fluorine ions is 1:2 in the crystal. When you do a ratio, you always use a colon, which is the key to the right of the L button. So hit shift and then you'll get a colon. And you have to put them in the same order they ask for. So calcium was asked for first, you have to write calcium's number first. Fluorine was asked for second, you have to write fluorine second. Crystals of ionic compounds are found in many shapes and colors. In fact, minerals in gem shops are all ionic crystals. So here's one: cinnabar, pyrite, fool's gold, and hematite, which is iron 3 oxide. Huh, I didn't know that was hematite. That one's really pretty, I think. It's black. Fool's gold and cinnabar. All right, if I run out of time, just hit pause and read the rest yourself. Metals and nonmetals form ionic compounds or salts. Salts are formed from metals and nonmetals. nonmetals gain electrons, become an anion. Metals lose electrons